What we're going to do now is take that information of our number of protons, electrons, and neutrons and use that to draw diagrams of the atoms. The type of diagrams we're going to be drawing are called Bohr-Rutherford diagrams. Here's a little rule before we start. Because we know electrons are zipping around the nucleus in energy levels, we have to be able to know how many electrons can go in each energy level. So our first energy level, we're going to have 2 electrons that can zip around in that thing. The second energy level is going to hold 8. For our level right now, for our purposes, we're going to say the third energy level can also hold 8. And then that fourth energy level can go up to 16. We usually only go up to about 2, so we don't really need to worry about the other 16. Alrighty, so the best way to do that is just get doing it. Let's start with an example. So here we have our helium. We have our standard atomic notation for helium. So we can figure out our number of protons, electrons, and neutrons in an atom of helium. Our number of protons is equal to the atomic number, which is 2. Our number of electrons, because we have a neutral atom here, our number of electrons, which are negative, are going to be equal to the number of protons, which are positive. So because that's 2, this is going to be 2. And our number of neutrons, we take our atomic mass minus our atomic number, and that gives us our number of neutrons. So this tells us that in the nucleus of the atom, we have 2 protons. And in the nucleus of the atom, we have 2 neutrons. So this is our nucleus. Right? And then we know around the outside, we've got our first energy level. Now, in real life, there's not going to be a dashed line around the nucleus of the atom, but that's just there to represent our first energy level. So we need to place 2 electrons. So we're going to place 1 at the top and 1 at the bottom, because these guys are both negatively charged. They're going to try to stay as far away from each other as they can. Our next example is carbon. So for carbon, we have our protons, electrons, and neutrons. So our protons, we have 6, because equal to the atomic number. If we have 6 positive protons, that means we must have 6 negative electrons. And then to find out our number of neutrons, we take our atomic mass minus our atomic number, and that comes out to be 6. So in this atom, we've got 6 protons in the nucleus. We've got 6 neutrons in the nucleus. Here's our nucleus. Around the first energy level, we've got 1, 2 electrons. But we've got 6 in total. We need to place 6. So now we need to go to our second energy level and start to fill in the spots there. And we're going to fill them up in this order. So we're going to do 1, 2, 3, 4. So we're going to around the circle 1 by 1. So now we have 1, 2, 3, 4, 5, 6 electrons circling around the outside of our nucleus. So that's what our carbon looks like. The next one we're going to do is phosphorus. So for phosphorus, we have our protons, electrons, and neutrons. So our protons, 15. If we have 15 positive protons, that means we must have 15 negative electrons. And if we want to figure out our number of neutrons, we take our mass, we minus our atomic number, and we get 16. So in the center of the atom here, we have 15 protons. We have 16 neutrons. Here's our nucleus. We have our first energy level here. So now we have to put 15 electrons around the outside. So first energy level gets 1, 2. Our second energy level is going to get 1, 2, 3, 4, 5, 6, 7, 8. Now, I know these are drawn side by side, but in real life, 1 electron is up here and 1 electron is down below the circle. So they're not beside each other. They just are drawn that way. So we got to do 1 more energy level here. All right, so our third energy level, we have 5 more electrons to place. So 1, 2, 3, 4, and 5. So this is kind of what our phosphorus looks like. Now, remember again, We've drawn them in 2D, but in real life, they're zipping around in all sorts of different directions in their energy levels. So this is actually a 3D atom, but we've had to just draw it flat as 2D. Let's try one more before you work on the worksheet. Let's try aluminum. Aluminum, the mass is 27. The atomic number is 13. So for our protons and electrons and neutrons, we know we have 13 protons, we know we have 13 electrons, and for our neutrons, we know we do 27 minus 13, which gives us 14. So we've got 13p in our nucleus, we've got 14n, all right, and then we have to place 13 electrons around the outside. So our inner energy level, we've got 1, sorry, 2,